welcome to Yogurt Day. On pre-Yogurt Day.
Oh yeah.
Thank you. Yeah. Okay. That was studio audience. So exciting on pre-Yogurt Day.
It's
we talked
lit.
about the 1 cup scoopers. Well, the 1 and 1/3 cup scoopers are here. We said that the 1 cup scooper was having an expected value of 1 cup. And you might be wondering, where is the yogurt? Well, right here we have
Excellent
32
camera work.
ounces.
Wow.
But it's not really 32 ounces.
Is that
it?
32? Let's show the camera.
Because-
Show the camera. Come here.
Think
Is
about
it really?
that.
Strawberry.
Wow. Okay,
Think about
good.
that. I mean, if you can imagine molecules of strawberry yogurt, do you think every single 32 ounce, that's 4 cups, 32 ounce container of Chobani yogurt, you think it has exactly the same number of molecules?
Yes.
No, actually, they don't. No. There's a mean and a standard deviation. So it's probably normally distributed with a mean and a standard deviation. So what we're going to do is, the goal for today is to get 2 1/3 cups of strawberry Chobani yogurt from here into the bowl, and we're going to purposefully go in a circuitous manner. Instead of just going 1, 2, and 1/3, we're going to do like what sometimes happens to me when I'm cooking. 1, 2, 3. It's like, oh, rats, I did too many. And then we're going to subtract. We're going to take out 1/3 cup and 1/3 cup. So there's going to be 5 random events.
I don't think it's
X1
random if you told us
plus
what to do.
X2 plus X3, and then we're going to subtract minus Y1 minus Y2. So yesterday we learned that this cup has, on average, you get 1 cup of yogurt, but there is sometimes overfill, sometimes underfill, so standard deviation of 0.3. And the 1/3 cup scooper, Katie, can you verify, does that really say 1/3 cup? Okay, so on
Sure.
average, every time we use cup Y, average is 1/3 cup, standard deviation 0.15 cups. Okay, so now, it's important that you capture what happens on Yogurt Day. We're going to take a look at your pre-Yogurt Day sheet. Let's continue, but now let's add to it. Let's write Yogurt Day.
Is that today?
Today, Yogurt Day has come.
Oh, it is.
And it's not time to
Yes.
open the yogurt up. You'll know.
Blast.
You'll know when it's time.
I can
But-
smell the yogurt from right here.
I'd like you to write down, I want you to capture Yogurt Day.
Yogurt's awful.
There's something I need to hear, because I'm all
I'm
ears.
partially allergic to dairy.
Okay, so are you
That's very
allergic
sad.
to the fragrance of
Oh, no,
dairy?
no. It just makes my stomach upset.
All right.
That's fine.
Okay, so are you feeling okay right now? Yogurt Day is about the Pythagorean theorem of statistics. So please jot this down, please capture this. Yogurt Day is about, it's all about the Pythagorean,
Oh, I thought that said yogurt day is a boat.
is about the Pythagorean theorem
Yogurt Day is like
of
a boat.
statistics. Now we're going to compare the Pythagorean theorem of statistics to the Pythagorean theorem of geometry. So let's do a 2-column comparison in geometry compared to in statistics. Let's write in all caps, that lasted for only like a day. They're both if-then statements. If-then. Now, what is the if-then statement in the Pythagorean theorem? Does anyone know?
If it is a right triangle.
If you have a right triangle with side lengths, legs, length A, B, and hypotenuse C, then does the Pythagorean theorem say that C is equal to A plus B? Is that what the Pythagorean
No, it
theorem
does not, Mr. Royce.
No, it's not. It's not C equals A plus B. What is it actually?
A squared plus B squared equals C squared.
Yeah, it's C squared.
squared
This hypotenuse squared is leg squared plus leg squared. Likewise, in the Pythagorean theorem of statistics, it's like we have a right triangle in which we have the standard deviation of a 1 cup scooper, X, on one leg, and the standard deviation of a 1/3 cup scooper here on that leg, and on the hypotenuse we have the standard deviation of X plus Y. Just imagine taking a 1 cup scooper globular yogurt and a 1/3 cup scooper. It's like, how would we find it? Well, it turns out, wouldn't it be nice if you could come into class and learn that the standard deviation of x plus y is the standard deviation of x plus the standard deviation of y? Wouldn't that be a great lesson? So easy to remember. Is this true or false?
False.
It's actually false. In the same way that c equals a plus b is
It's
false in the
squared.
Pythagorean theorem, it's squared. It turns out that, in fact, you know what, let's write down what is not. I want to make sure you understand. This is not the case. Standard deviations do not add. You cannot distribute standard deviation across x plus 1. Here's what is true. What is true is that just like in the Pythagorean theorem of geometry, the standard deviation of x plus y squared is the standard deviation of x squared plus the standard deviation of y squared. Oh, what is the concept that we learned? What's the name of the concept for standard deviation squared?
Variance.
Variance. So it turns out that the variance of x plus y is in fact the variance of x plus the variance of y. So that is true. You can actually distribute variance across x plus y. You cannot distribute standard deviations. Standard deviations don't add. Variances add. Now, there's if that's all we were learning today, then you would not need yogurt cake. But there's more to this. We don't always just add. Sometimes
We subtract.
Sometimes we overfill the bowl and we have to take some out. So we are responsible for thinking about, we'll fit to height and fit to width. We're responsible for thinking about the variance of x minus y. True or false? The variance of x minus y equals the variance of x minus the variance of y.
True.
False.
That
Okay,
is
so
so
we- some say
false.
true,
It's not
some
even
say
funny.
false. The truth is that this is false.
Get out.
And this is why we need yogurt day, because it's counterintuitive that variances add even when we subtract random variables. And this is a point at which some students who don't have a yogurt day experience say, that's it. You want me to believe that this is true? I'm done. No more math for me. I'll never understand it. So it turns out that the Pythagorean theorem of statistics is analogous to triangles, the Pythagorean theorem of geometry, but it's really not about triangles. It's not about right triangles, it's about independence. So here it is. The Pythagorean theorem of statistics really says if x random variables x and y are independent. Variables x and y are independent. Then the variance of x plus or minus y, it matters not whether we're adding or subtracting, is the variance of x plus the variance of y. And the fact that you add even when you're subtracting is cause for going above and beyond and pulling out the yogurt. The time has come to illustrate the Pythagorean theorem of statistics with actual yogurt. Now, we
Woo!
don't want just anybody watching this. I'm just going to close the door.
You are such a good video.
I really am,
Not
honestly.
only is door closing soon.
Whoa.
Whoa. Whoa.
No, if anyone-
Grandma, your arms
I
are.
tried to
They
put down
are,
the shade
yes,
over
that
there.
is very
Tried to
true.
put down the shade, wasn't working, so if anyone tries
Do you want me to be a security guard?
No, you're
I
fine.
can go over there.
Thank you for offering this.
Oh, you're welcome.
So here we go.
Good man right there.
What we're gonna do is we're going to try to get 2 1/3 cups of yogurt in there. So hang with me here while I look at, yeah. Okay. Here we go. Now, the time has come.
Oh, no.
Happy yogurt day.
Yes.
Yay!
People are always wondering, now, do I get to eat yogurt on yogurt day?
Get a
Oh,
spoon
that's
in your
yet
soup
to
Yeah, I
pocket.
know.
You get to
What
what
you
you
get?
get.
Do you always have a spoon in your soup pocket?
Are you gonna double dip that spoon?
I'm not putting spoon there.
You don't like it?
I do, but I'm on I'm on YouTube right
Oh,
now,
oh,
so.
okay.
Oh, and you have the napkins too, that's good. Class touch.
I have a goatee. Looking at it would be a little high risk.
Yeah.
Not professional enough
No.
for you.
This is after all this is Wheaton Academy.
We have carpet.
No.
It's not a yogurt on the carpet.
So, if, I think Mrs. Cheney did give students permission to borrow, she gets some spoons over there. So afterwards, if you want to snarf up one spoon, if you want to snarf up a spoonful of yogurt. For now, it's math first, yogurt second. So, my strategy is gonna be to pretend that I've overfilled, I'm gonna go X plus X plus X, and I'm gonna, so here's the first scoop.
It's
That's
globby.
way
Does it look
more.
overfilled
Dude, that's
or
like a
underfilled?
That's way
cup and a
more.
half right
It's kind
there.
of globby, isn't it? Okay,
Very cool.
so
That's exactly what
X1 has just, that's a random event. X1 just
Overfilled
happened.
it.
No, it's
No.
perfect, Marcus. You didn't see.
It's
Right
It's
under.
under.
Looks
Oh, it's
underfilled.
under.
Looks kind of underfilled. X2 has just happened. So far, we would model what's happened with X1 plus X2. And so I need 2 1/3 cups of yogurt.
That's not a good idea then, Mr. Royce, to put that cup.
Don't do it.
Don't do it, please.
You just need a third. Don't make the mistake.
Wait,
No.
what are you saying?
No.
Oh, you're saying don't do it?
Yeah.
Ah! I just did. Okay, so
No.
I'm trying to be sanitary about this.
I don't
I'm
think
not
it's
like-
It's not
sanitary.
working.
Putting my hands in there.
Okay.
Okay, so now I've done X1 plus X2 plus X3.
It's very
Now-
sad smell.
Oh, by the way, after I put the first scoop in,
Yeah,
I then put the second scoop in. Wait, I've got a question for you. The variability either increased or decreased after I put in the second scoop. Was there more uncertainty about how much yogurt is actually in there when I put in the second scoop, or less uncertainty?
More.
More
More.
uncertainty. And then after I put in the third scoop,
More.
there's even more uncertainty. Okay, now when I subtract a 1/3 cup scooper,
There's gonna be
More.
is there gonna be more uncertainty about how much is in the bowl or less?
More.
Yeah, even though I'm subtracting,
You're adding.
variability has increased. And I'm gonna subtract again, does that increase or decrease the uncertainty or the variability?
Increase.
I am so uncertain right now.
Variability, so variances increase,
I have
variances
zero clue
add,
how
even when I'm subtract, you just,
There could be.
You
a
My
challenge.
confidence level is
witnessed-
0.
the Pythagorean theorem of statistics, variability, so the variance adds even when you subtract.
Wait, variance is
Marcus,
variability?
clap.
Variance is a measure of variability. Just like the square root of variance, the standard deviation is a measure of variability. So, when I say go, I'd like all of you to say out loud and in unison. Variances add. In fact, let's connect it to this. Let's say variability increases even when you subtract. Ready? Go.
Variability increases even when you subtract.
So,
Fascinating.
that's part of it. But there's, and you might think, couldn't get any better.
I highly doubt it, Mr. Royce.
It's not over. There's more. There's more.
It can.
No,
way.
stop. That's cap. He's capping.
No,
There's
it
no
gets-
way.
In fact, it gets even, not even better. What's to come is way better than even what just happened.
No.
Okay?
Whoa.
I know
Hey.
you don't believe it. You don't
Stop
believe it.
it.
Thou shalt not lie.
So, friends, here we go. This is our first example. Let's calculate the expected value of what happened. In fact, let's think about the expected value of x1 plus x2 plus x3. And how does it compare to the expected value of 3x1? Is it a greater than, a less than, or an equal to relationship? Well, in order to answer that question, you need to know how to think about 3x1. You know how to think in the real world about x1 plus x2 plus x3. That's 1 scoop. Randomly add another 1 scoop amount of yogurt, then a third one. We know what that is. But what is this? This is where it gets even better.
Yes, sir.
What is 3x1 in the context of yogurt? I'll tell you what it is.
So you
The
have
first scoop.
On Monday. No, I'm telling you today. I'm gonna tell
First
you what it
scoop.
is. That's what happens when you yogurtize a cup of yogurt. You need the yogurtizing machine. Okay, so what is a yogurtizer? A yogurtizer, it's like, I would say magic. Maybe you grew up in a house where your parents tried to steer you away from thinking about magic. Maybe magic wasn't the thing for you. So we don't have to use the word magic. Maybe you can just think of
A miracle.
the amazing miracle that happens when the universe was spoken into being. Words, and then all of a sudden we have the universe. It's kind of like someone essentially spoke the internet into being. It's like they imagined it and then it came into being. That's a lot like what happens with the yogurtizer
Spiritual
machine.
chicken?
Attach meaning to.
Or when you attach meaning to symbols with words, that's the kind of awesomeness that we're talking about.
His
Attaching meaning to
Face just
symbols
lit
with words.
up.
The yogurtizer. Now the yogurtizer is an imaginary thing that, just imagine that you got a cup of yogurt. This is the 1 cup scooper, and someone put some yogurt, it's like someone's pranking around and they put green food coloring in the yogurt. So suppose it's not exactly 1 cup, suppose it's 1.03 cups. And then it travels by conveyor belt to the yogurtizer, comes into the yogurtizer, and this is the 4x yogurtizer. This, instead of multiplying by 3, it multiplies by 4. And it's an amazing thing. It takes however much yogurt there is, it goes through the yogurtizer, and guess how much yogurt is in the cup when it comes out?
4.12
Cups of yogurt.
It's it's
Amazing.
almost like magic. It's like now,
That's a
instead of, after it comes out of the yogurtizer, it just, it gets, now we have exactly, if you multiply it by 4, it's 4.12, it's exactly 4.12, down to the molecule.
That's ridiculous, Mr. Roy.
So that's what I'd like you to compare. What is the expected value of x1 plus x2 plus x3 compared to x1 yogurtized into 3 times exactly whatever randomly showed up? Equal, greater than, or less than?
Greater than?
It turns out that with expected values, there's no mystery. They are equal. The expected values are equal, but
Oh, rip.
the variance of x1 plus x2 plus x3 compares how to the variance of
That's
3x1.
Oh, it's so much greater.
Okay, so I'm hearing people say, because it's either greater than, less than, or equal.
I'm gonna go with option number 1.
I'm hearing greater than. Raise your hand if you agree with greater than. Is there anyone in the greater than camp? I see 1, 2, 3.
Oh, that's me.
Okay, so everyone. It turns out it's not greater than, and it's not equal.
I'd say less
Stop.
than.
What?
Why would it be less than? You've just had the yogurt experience. Why would there be less variability in x1 plus x2 plus x3, 3 individual scoops of yogurt compared to 1 scoop of yogurt magically multiplied by 3? Can someone explain why there would be less variability in this scenario than in this scenario?
The shape is
Because it could go over and under, and they
Could go over, under. So it's like overfilled, underfilled, so it's closer to 0 variance.
But it could be the other way around.
It
right?
could be
It's
the
just
other way
over,
around.
over.
But
Could be under, under,
we're
under.
trying to create,
Ooh.
it could be, but on average, there's going to be more variability because here, whatever the error is,
It's multiplied.
gets multiplied by 3, gets magnified every time. So on average, there is less variability in this real world scenario than in the yogurtizing scenario. So that's very counterintuitive. Every year, it's very rare for someone to say less than. I think it was my 3rd year teaching AP Stats. Here's my 11th year teaching AP Stats overall. It's very rare for people to say less than because people have hearts that are fallen and they tend to tell lies. So if you're like one of those follow your heart, be true to yourself, listen to your heart kind of people, that's risky. That's risky because sometimes your heart lies. And we experienced it all here today. All 5 of you heard a lie.
Big class.
All 5 of you heard a lie from your heart
This
today.
is like the math
So,
labs for
now-
the
This is what I'm saying.
This is like the math labs, you know, for the people who aren't as good as math. That's
Oh, right.
class.
Five of us.
Yeah,
Mhm.
All right, so
Are
next.
you dissing a math class?
My dad.
Yeah, man.
Yogurtizing. All right, here we go. So now we're going to look at the expected. Yes, question.
Oh, no, I was kidding.
So that was problem 1. Now for problem 2. Now let's do some actual math where there's numbers involved. Let's look at the expected value of x1 plus x2 plus x3 minus y1 minus y2. Let's find the numeric answer to this problem.
Let's do it.
Well, it turns out with expected values, there's no mystery. We don't need yogurt day for this. It's just the expected value of x1 plus the expected value of x2 plus x3 minus the expected value of y1, a 1/3 cup scooper, minus the expected value of y2. And we know from yesterday, we know that this, it's 1 plus 1 plus 1 minus 1/3 minus 1/3. Why is it not acceptable to write 2 and 1/3 as the answer?
Because you need units.
I need units, and the units are
Cups of
so
yogurt.
the expected value of what's right in here, we expect on average, if it's normally distributed, there's a mean 2 1/3 cups. There is a standard deviation. We want to calculate the standard deviation. We didn't have enough. Without the Pythagorean theorem of statistics, we cannot calculate the variance of the amount of yogurt in here. Neither can we then take the square root of the variance to get the standard deviation. So we need the Pythagorean theorem of statistics to get that. So here we go. What is the variance of the amount of yogurt x1 plus x2 plus the model? The random variable model for what we did today was x1 plus x2 plus x3 minus y1 minus y2. Well, the second line for expected value was these 5 terms. There are 5 terms in this
Just add them
second
all
line down here. Can someone tell me what to write down? Just like what specifically should I write? Tell me what to write. I'll write down. Go ahead.
EX1, E
So
left
say
parentheses,
say variance of x1
variance of x1 plus variance of x2 plus the variance of x3 plus the variance.
You're
of
adding
y1.
variances,
Yes, I am.
but we're subtracting random
But
variables.
It doesn't matter because the yogurt and stuff.
Variances, are you telling me variances add even when we subtract?
Yes, I am saying.
So it's
that.
variance of y1.
Plus the variance of y2.
Again, you're adding every time?
I think so.
So there it is. Now class.
What?
I'm there.
You're adding?
So,
I don't know how to add Mr. Lewis.
so we're adding the variance. Now, we learned the standard deviation for x was 0.3, so the variance is 0.3 squared plus 0.3 squared plus 0.3 squared plus 0.15 squared plus 0.15 squared. So even though we could type that into the calculator, I would recommend you combine like terms. We don't really go to the calculator until we combine like terms to get 3 times of these 0.3 squareds and 2 of these 0.15 squareds. Now's the time to go to the calculator. Let's calculate the variance. I've got my calculator all the way up. Take it out and let's type in 3 times 0.3 squared plus 2 times 0.15 squared. So we found the variance.
What?
We didn't know that walking in.
Say
You probably didn't know
what?
that the variance of the amount of yogurt here is 0.315 cups. 0.315 cups. And if someone asked you to find the standard deviation of x1 plus x2 plus x3 minus y1 minus y2, you would just take the square root of 0.315 to get, according to my calculator, the square root of 0.315 is somewhere around 0.5612. So I'm going to use the wavy equal sign 0.5612 cups is a standard deviation. Wow. Variances add even when you subtract. Now, a lot of times students skip the variance and they go straight to the standard deviation, which is fine. Just like when you're trying to find 3, 4, when you're trying to find 5, it's find solve for C. Sometimes students go straight to this. I'm just going to take 3 squared plus 4 squared. It's like the variances, and take a squared plus b squared, take the square root. C is the square root of 25, and C is equal to 5. So just like finding standard deviations is a lot like finding the hypotenuse of a triangle. It's like C equals the square root of a squared plus b squared. It's like a squared and b squared are the variances that are adding up. So likewise, when students are trying to find the standard deviation of x1 plus x2 plus x3 minus y1 minus y2, oftentimes they'll just go straight to the square root of 0.3 squared plus 0.3 squared plus 0.3 squared plus 0.15 squared plus 0.15 squared. They will often then do a little more paper and pencil work. They'll go 3 times 0.3 squared, 2 times 0.15 squared, then they'll go to the calculator. So the calculator work, we're going to do a GFA problem right now.
Oh, no.
And so would you just practice the kind of calculator work that you're going to be doing? If you don't have a calculator, is there anyone who does not have a calculator with them today? Because everyone needs a calculator for GFA. And you have one? No? Okay. So I would like you to type into your calculator, just to make sure you know the kinds of things that I'm going to be looking for when I look at your desk. I'm going to be looking for the square root of 3 times 0.3 squared plus 2 times 0.15 squared. That's what I expect to see when you're calculating standard deviations using the Pythagorean theorem of statistics. Okay, so that's what it all comes down to. So here we go. GFA problem number 1. I'm going to give you an answer sheet, one answer sheet per group. And I provided you with some stapled documents. These stapled documents are for recording your GFA problems, which start today and continue until Monday. So this is a 2-day GFA activity. And there's probably going to be a time where I'll give the problem, and then we can pause the camera. Just don't, if you're late since you're doing camera work, fold the sheet, not the I'm not going to say which way to fold it. I'm just going to say not the hamburger way, okay?
The hot dog one.
Not the hamburger way. So fold it the other way, all right? And then open it up, put your names in the upper right-hand corner. Here we go. The first GFA problem.
Mr. Royce, did you know this looks like a hot dog bun? Did you like fold it like that?
I'll have to think about that. Now, so GFA problem number 1. Here we have a new problem. It's new cups. It's not 1-cup scoopers anymore, friends. I know you like the 1-cup scoopers. They're gone. We've got a 5-cup scooper. So so we have a new random variable, a new scooper, 5 cups. Can you imagine this? 5 cups in 1 scooper? And the standard deviation of this scooper is 0.3 cups again. Then we have another scooper. It's a 2-cup scooper. And the standard deviation of the 2-cup scooper is 0.1 cups.
Oh.
0.1 cups. Okay, here's GFA problem number 1. I would like you to find the standard deviation of going for 3 cups of 5-cup scooper minus a 2-cup scooper. So the expected value of x minus y is 3 cups. Would you please find standard deviation of x minus y? You can pause it. Is the square root of standard deviation of x minus y squared, which is the variance of x minus y, plus the standard deviation of x minus y squared, which is the variance of y. I'm sorry, I said x. That's just standard deviation of x squared, which is the variance of x, plus standard deviation of y squared, which is, so it's a lot like, this problem is a lot like finding the hypotenuse of a triangle. It's like c equals the square root of a squared plus b squared. The calculator work, square root of 0.3 squared plus 0.1 squared, would have been this. This is what I was hoping that everyone would have on the calculator when I toured the room, square root of 0.3 squared plus 0.1 squared. Variances add even when you're subtracting random variables. The answer was not simply, I wonder if there's any way to get this from that here onto this document.
Oh, that's crazy.
No.
I just,
That's not the right
my
answer.
heart told me to just My heart doesn't always lie. And so this time
That's not the right answer, Mr. Royce.
came out to be approximately 0.3162 cups. Okay,
Yogurt.
so now, okay, so some of you are like, oh man, I didn't get, you're gonna have a chance to redeem yourselves. Because you only have to get 33% or more, or 66% or more. So let me return. Do you have any questions on the first GFA problem?
No fish
Okay,
buddies.
now,
GFA.
next problem.
Stop.
GFA number 2. Actually,
bounce back.
This is
Last night I been ill, but
GFA problem number 2. I would like you to, same X, so X is, it's a 5-cup scooper, standard deviation 0.3. Y is a 2-cup scooper, standard deviation 0.1. I would like you to find the standard deviation of x1 plus x2 plus ... plus x sub 10. We're going to take 10 scoops with
Whoa.
the 5-cup scooper minus y1 minus y2 minus y3. Please find the standard deviation of, we expect this, by the way, to be 5 to 50, 48, we expect it to be 46 cups on average. What will the standard deviation be? So please find the standard deviation. This is the GFA problem. Go ahead and pause it. Okay, here's what I would expect to see for the setup. You could do a preliminary step. Ideally, you're doing the variance of x1, so it's going to be 0.3 squared plus 0.3 squared plus. You probably don't want to write down all of them, but you can indicate, okay, there's 10 terms here, plus 0.1 squared plus 0.1 squared plus 0.1 squared. So that's conceptually what we're going for. But you don't want to take the time to type that into your calculator. My coaching for you would be to not do this piecemeal. Don't do like little pieces of the problem, you might lose track. Instead say, look, we've got 10 of these 0.3 squared things, and we have 3 of these 0.1 squared things. This, I would actually type that into the calculator. I think when you're on the AP test, that's the best use of your time. Just type in the square root of 10 times 0.3 squared plus 3 times 0.1 squared. Nothing more, nothing less. This is a nice, efficient way to get 0.9643 cups. 4 cups. Any questions on this GFA problem? Okay, so we're done. And now for a little bit of a break before we go to GFA 3. So this is called a GFA break. That's what we call it in the industry. It's time for a GFA. It's similar to a bacon break, but instead of eating bacon, we're going to compare, check this out, the expected value of x1 plus x2 plus ... plus x sub 10 to the expected value of yogurtized 10x1. How do those compare? Equal, greater than, or less than?
Equal.
Yeah, they're both 50 because it's 5 plus 5, so they're equal. Now, the question is, what would the standard, let's go straight to standard deviation, x1 plus x2 plus ... plus x10. Let's actually calculate both of these, the standard, I'm sorry, they're not equal. But how would you calculate both of these? Standard deviation of 10x1. Okay, so this one would be just the square root of, wouldn't it be like 0.3 squared plus 0.3 squared, 10 of these things? It would be 10 of these 0.3 squares. Let's find out what that is. Because I mean, I tried to argue earlier today that there's actually less variance here, and therefore the standard deviation is going to be less here than there. Let's see if that's really true. Let's type in the standard deviation of x1 plus x2 all the way up to x10. What is the square root of 10 times 0.3 squared? Okay, so it's 0.9487 cups approximately. 0.9487 cups. Okay, what is this? How do we handle the yogurtized situation? Well, what effect does multiplication have on the standard deviation of x1, which is 0.3? So if you multiply, we learned this first semester. Like when you add things onto random events, the standard deviation is what? Changed or unchanged?
Unchanged.
Yeah, if you add something to every member of a distribution, it has no effect on the standard deviation. How about if you multiply every member of the distribution by 10? Yeah, that does affect it. So the standard deviation of 10x1 once you yogurtize x1 by a factor of 10, its new standard deviation is now 10 times 0.3. So the variance, we have to take the square root of the variance to get the standard deviation. The variance would be 10 times 0.3. The whole thing is squared. Instead of only the 0.3 being squared, it's 10. So which one is bigger? Square root of 10 times 0.3 squared, or the square root of 10 squared times 0.3 squared? Which of these two numbers is going to end up being bigger? That one's bigger. In fact, look, it's the square root of, it's 10 times 0.3, which is 3. Wow, it's a lot bigger. It's a lot bigger. We predicted it, your heart told you otherwise, but now we've seen it really is true. That the reason the standard deviation is so much lower when you're just doing 10 scoops, 10 5-cup scoops, is that there's over, under. It's like overfill, underfill, and then, so you get much less standard deviation than if you yogurtize, because whatever error was there, it gets magnified by a factor. It's huge. So now we've seen it in calculation form. Now for the last GFA problem of the day. The GFA break is over. Now, was that your first ever GFA break?
Yes.
Okay, so now GFA problem number 3, and wow, this is becoming a challenge problem. What is the standard deviation? It's a 5-cup scooper, 2-cup scooper of 2x1 plus, oh, no, okay, so we'll do this problem on Monday. Your only homework is to read chapter 16 of the book. Read that for
Plus.
Monday,
Can we watch the podcast?
and yes, you can. So-
All right.